Good morning. Uh, Picking up where we left off last week, we graphed sine functions, and cosine functions. And today, in this video, I want to talk about the tangent function, and also page 384 in your packet. We'll go through a bunch of examples. Okay, so just to refresh your memory on the sine graph, just the regular y equals sine of x. Remember, the general form is y equals c plus a sine or cosine of b times x minus d. You remember, each one of these things does some kind of transformation from your basic parent function for the sine function or the cosine function. The basic parent function, your period goes from 0 to 2 pi. One full cycle goes from 0 to 2 pi. Now, this is the biggest difference between a sine function and a tangent function, because one cycle of the tangent function does not go from 0 to 2 pi. It actually only goes from 0 to pi. Okay, so let's take a look. And remember how we graphed this initially. We graphed some key points, x versus y, and we graphed at the angle 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then looking at the unit circle, at this point right here, 1 comma 0, the sine of the angle of 0 would have been the y value 0. Once we get to pi over 2, 0 comma 1, the sine of pi over 2 is the y value up here, 1. Over here, your y value is 0. Down here, your y value is negative 1. And then at 2 pi, your y value is 0. So that was how we got those points. So we're going to do the same thing, but for a tangent. Okay? So for a tangent function. So let's take a look at what this is going to look like. Let's pick some x and y values, x and y. Now, if we've got the function y equals tangent of x, let's look at the unit circle here. And here we're going to pick a couple more points. So we're going to say at 1 comma 0. Remember, the tangent of your angle is the y value over the x value. Okay, so here it's going to be the y value over the x, 0 over 1, which is 0. So that's when your angle is 0. We're right here. The tangent of 0 is 0 over 1, 0. Okay, now let's do at pi over 4. Okay, at pi over 4, because this point right here, that gives you a 45, 45, 90 triangle. So you would draw this. The two sides of your 45, 45, 90 would be rad 2 over 2, rad 2 over 2. Okay, so the tangent of pi over 4 would be the y over the x. That's rad 2 over 2 divided by rad 2 over 2, which is just 1. Okay, now let's go up to an angle of pi over 2, or 90 degrees. At pi over 2, that point right here is 0 comma 1. So the tangent of that would be the y over the x, 1 over 0, which is undefined. Okay, now let's go over here at 3 pi over 4. And the tangent of 3 pi over 4 is, so this point right here, similar to this point, except your x value is negative. So that's going to be negative rad 2 over 2, comma, positive rad 2 over 2. So the tangent of that angle, 3 pi over 4, is going to be the y over the x. So it gives you a rad 2 over 2 divided by negative rad 2 over 2, which is negative 1. And then once we get over here, pi, when your angle is pi, this point right here is negative 1 comma 0. The tangent of that would be the y over the x, 0 over negative 1, which is back to 0. So as you can see, from 0 to pi, we've gone through a full cycle. And if we do the same thing on the bottom half of the circle, we're going to go through these same values again. We could do that really quickly. At this point right here, again, you'll have a 45, 45, 90. Your y and your x are both negative. So a negative rad 2 over 2 divided by negative rad 2 over 2 gives you positive 1. That angle right there would be 5 pi over 4. Each one of these is 1/4 of the way to pi. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So at 5 pi over 4, the tangent of that angle would be would be 1. But once we get over here, that's 6 pi over 4, or reduced to 3 pi over 2. At that point right here, 0 comma negative 1. y over x, negative 1 over 0, that's undefined. And then over here at 7 pi over 4, your tangent of 7 pi over 4, that's going to be rad 2 over 2 comma negative rad 2 over 2. So negative rad 2 over 2, the y divided by the x, over positive rad 2 over 2 gives you a negative 1. And then back to 2 pi, back to this angle of 0 or 2 pi, y over x is going to be 0. So you can see from here to here, you've gone 0, 1, undefined, negative 1, 0, and then it repeats 0, 1, undefined, negative 1, 0. It only took 0 to pi before it starts repeating. Okay, so your period for the tangent function is only pi instead of 2 pi. Okay, so let's graph this. 0, 0, that's this point right here. Pi over 4 comma 1, so I'm going to go up by pi over 4s. Pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, that's pi. Let's go back this way. At negative pi over 4, negative 2 pi over 4, or negative pi over 2, negative 3 pi over 4, and negative pi. Okay, we could go further, but let's just do this for now. So 0 at pi over 4, we're at a value of 1. Pi over 4 comma 1. And at pi over 2, we're undefined. So we're going to actually have an asymptote there. Okay. And then at 3 pi over 4, our value is negative 1. That's going to be down here. At pi, our y value is 0. So that's going to be here. Let's do 5 pi over 4. We're going to be back at positive 1. And then at this point right here, 3 pi over 2, we're undefined. So we have another asymptote. Okay. So you can see that this function is going to go like this. Okay. We could continue and draw another cycle over here, but let's continue going this way. At negative pi over 4, we didn't put that in our table, but looking at this at negative pi over 4, that's going to be down here. Okay, it's same as 7 pi over 4, where y value was negative 1. Sorry, this 0 down here. Let me finish that off. That's 2 pi comma 0. Okay. But at negative pi over 4, down here we have a value of negative 1. And at negative pi over 2, that's going to be the negative 1 over 0. That's undefined. Okay. And this is what your tangent function looks like. Okay. A couple key things to note about the tangent function. Notice there's no max or min. This goes up and will go all the way. The y value will go all the way up to positive infinity and down to negative infinity. So if you wanted to know the range of this function, the range of this function would be all real numbers. Okay, that's different from your sine and your cosine functions, which do have a clear max and a minimum value. Okay, now if we want to name a couple things about this function, let's do the amplitude, period, the vertical shift, and the horizontal shift or phase shift. It could be called either. Okay. Amplitude, there isn't an amplitude because amplitude technically is defined as your maximum value minus your minimum value, this distance here, divided by 2. Because remember, amplitude is the distance from your wave axis or your midline up to the top or midline to the bottom. That's defined as your amplitude. The technical definition of amplitude is your maximum value minus your minimum value divided by 2. Okay, so since there is no max and there is no min, there is no amplitude. However, there is an A value. The A value here is 1, and the A value means something. Okay, so your A value is equal to 1, even though you don't have an amplitude. That A value tells you at halfway between the center of your graph and your asymptote, at the pi over 4 mark for this function, your value is at 1. That's going to match your A value, coefficient of 1 before the tangent. Okay, and we'll see some examples of that. Okay, the period is 1 pi as opposed to 2 pi for this function. Vertical shift, here there's no vertical shift. And then phase shift, there's no phase shift. Okay, because this is your basic parent function. So we're going to refer back to this function when we do some transformations. Okay, so now we're going to go to page 384 in your packet. We're going to go through this one fairly quickly because the very first one on this page we actually just did. But I want to show you how you're typically going to graph these and how you want to practice these. So a tangent function, you know the period is pi. Okay, and what you want to remember, now we could graph this function between 0 and pi, but if you did that, you'd be going from here to here. You'd be graphing this part of this one and then the asymptote in this part of this one. There's nothing wrong with that. That's a full cycle. But you can pick a section from asymptote to asymptote also. You could pick this section or this section. We usually pick this section just because it's easiest, okay? So you take your period, and here, since the period is simply pi, we're going to go, notice where this graph is, half of the period to the right, half of the period to the left. Since the period is pi, we're going to go pi over 2 to the right and pi over 2 to the left. And that's negative, okay? Now we want our quarter marks. Remember, any of these graphs, we want to find the beginning and end, we want to find the middle, and we want the quarter marks, okay? So halfway to pi over 2 is pi over 4. Halfway between 0 and negative pi over 2 is negative pi over 4. We know our asymptotes are at pi over 2, and negative pi over 2. Remember, I'm doing this from your parent function. Pi over 2 and negative pi over 2 are your two vertical asymptotes. And then at our graph is going to go right through this center. The tangent of 0 is 0, so it's going to go through 0, 0. Halfway to our asymptote, we're at a y value of 1. Halfway to the other asymptote, we're a y value of negative 1. And you've got your tangent function. You only have to draw one cycle, okay? Now let's look at the next one. The only thing that changed about this one is there's a negative in front of it, okay? So let's do this, just get in the habit of doing amplitude, period. Amplitude, we'll do period, vertical shift, and phase shift, or horizontal shift. Amplitude, remember there's no amplitude for tangent. However, our a value is negative 1. That a value of negative 1 means your graph is going to be flipped. It's going to be reflected over the x-axis, okay? So your vertical shift, there's none. For horizontal shift or phase shift, there's none, okay? The way you're going to see these things, this looks a lot like your general equation for a sine or cosine, but here's what it's going to look like. Your general equation for a tangent is y equals c plus a tangent of b times x minus d. And all these things are the same. This c is your vertical shift, or your midline is y equals c. This a value, it's not your amplitude, but it does tell you something. It tells you where these quarter marks are. Okay, halfway between the middle of your graph and your asymptote is your y value up at 1, down at negative 1. If this is a 2, you'd be up at 2 and down at negative 2. Okay, so I'm just going to say it's the y value, or the value of the function at the, let's say, the first quarter and the third quarter, Q1 and Q3. Okay, that's not technical terms, but that's just note to ourselves. That's the y value at the quarter marks, okay? Period is going to be just pi. And the way you find your period, remember for the sine and cosine graph, the way you found the period was 2 pi divided by b, or if you're doing it in degrees, it would be 360 divided by b, okay? But that's because this function has a period, the parent function has a period of 2 pi. Now, since a tangent has a period of 1 pi, Our period equals 1 pi over b, or 180 over b. Okay, so that's the biggest difference, one of the biggest differences. Okay, your period is going to be 1 pi over b or 180 over b. Okay, our b value here is just 1. Remember, b is the coefficient of your angle. Okay, so we're just going to get pi over 1, so it's pi. Okay, now a lot of times when you graph this, we're going to first graph period is pi, so and there's no horizontal shift, so we know it goes through here. We're going to go half of the period to the right, which is pi over 2, half of the period to the left, which is negative pi over 2. So the distance from asymptote to asymptote is 1 pi. We're going to draw our quarter marks. It's going to be pi over 4 and negative pi over 4. Okay, at the quarter marks. Now this is the same, looks the same, but it's reflected over your x-axis or over your wave axis. Okay, that's because our a value is negative. This thing right here is going to reflect it. So it's just going to be upside down. So instead of being at +1, we're going to be at -1. Instead of at negative pi over 4, instead of being at -1, we're at +1. So everything just reflected. Okay. There's your tangent graph. Okay. Now we're going to see what happens here. The a value is different and the b value is different. So the a is 3. Let's do the amplitude. Remember, there's no amplitude, none, but the a value is 3, and that's important. Period we calculate as pi over b. Our b value is 2. B is the coefficient of your angle, so we're going to get pi over 2 for the period. Then we've got a vertical shift and a phase shift. There's no vertical shift, there's no plus c, and there's no phase shift, there's no x minus d in over here as part of inside of your tangent function. So none, none. You could say none or just not applicable, however you want to say that. None. Okay, so no vertical shift, no horizontal shift. Our period is pi over 2. So you know it's going to go through here. Tangent of 0 is 0. We're going to go half of the period to the right, which now is pi over 4. Half of the period to the left, negative pi over 4. So your entire distance, your period from asymptote to asymptote, has to be pi over 2. So this distance is pi over 4 plus another pi over 4. So this distance is, in fact, pi over 2. Halfway to the asymptote, halfway to pi over 4 would be pi over 8. Halfway to negative pi over 4 is negative pi over 8. And our y value here is not at 1, it is at 3 because our a value is 3. So 1, 2, 3, and 1, 2, 3, negative 3. So at the quarter mark, you're at 3. This quarter mark, you're at negative 3. There's one cycle of your tangent graph. You could graph another cycle that would go from pi over 4 to 3 pi over 4 for a second cycle. Okay. Now this one, let's do this one. Yeah, this one's going to be very similar. Your a value is 2. Yeah, we'll do this one. Amplitude, period, vertical shift, phase shift. There's no vertical shift. There's no phase shift. The period is going to be pi over b. B is 3, so the period's pi over 3. Amplitude, none. However, your a value is negative 2, and that's important. Negative means you're going to reflect it, it's basically upside down, reflect it over your wave axis. And then the 2 means that's where, at your quarter marks, you're going to be up at 2 and negative 2. Okay. No horizontal shift or phase shift. We're going to go half the period to the right. Half of pi over 3 is pi over 6. Negative pi over 6. So that distance from asymptote to asymptote is going to be pi over 6 plus pi over 6, so pi over 3. 2 pi over 6 or pi over 3. Halfway to pi over 6 is pi over 12 and negative pi over 12. Okay. At the quarter marks, we're going to be at 2. Normally we'd be up at positive 2, but it's upside down, so we're at negative 2. And at negative pi over 12, we're going to be up at positive 2. Okay, there's your tangent graph. Okay, now let's do a couple more just to practice. Okay, so these have horizontal shifts. We don't have any vertical shifts. If you did, this point and the whole graph would shift up or down. But let's do this one. Notice this one's in degrees. So we've got an amplitude, period, vertical shift, phase shift. Okay, there is a phase shift of right 5 degrees. There's no vertical shift. Okay, the period, normally the period is pi over b, but we're doing degrees, so it's going to be 180 over b. That's 180 over 9. The b value is that coefficient of your angle. 180 over 9 is 20. So 20 degrees is your period. The amplitude, again, there's no amplitude, but your a value is equal to 4. Okay, so let's graph it. Now, normally for all these graphs, we had a point that went through the origin, right? Because that was no horizontal shift. But now we're shifting right 5 degrees. So now instead of that point going through the origin, it goes through 5 degrees. So let's do 5 degrees over here. We've got a point that goes through there. And then we want half of the period to the right, half of the period to the left. Our period's 20, half of that is 10. So we're going to go right 10, which gets us to 15, left 10, which gets us to negative 5. There are your two asymptotes. So your distance from asymptote to asymptote, which represents your period, should be 20, and it is. Negative 5 to 15 is 20 degrees. Okay, so we're going to go through here at the quarter mark. We're going to be at a value of 4. Okay, so 1, 2, 3, 4. And at this first quarter mark, if we go halfway between center and this asymptote, we're at 0. So we're going to go down 1, 2, 3, 4, negative 4, and 4. So we should go through here. And your graph looks like this. Okay, and we'll do one more. Okay, amplitude, none, but your a value is negative 1, which means it's going to be upside down, reflected over the wave axis. The period, this one's in radians. That pi over 6 is our clue, it's in radians. So period's going to be pi over b. Our b value is 3, so pi over 3 is the period. And then vertical shift, we've got none. Phase shift, we've got left pi over 6. Okay. So we're going to go pi over 6 to the left. So at negative pi over 6, we're going to go through that point. Normally it goes through 0, 0, but we've shifted this point left pi over 6. The period's pi over 3, so we're going to go half of the period to the right, half of the period to the left. Half of pi over 3 is pi over 6, so I'm going to go half pi over 6 to the right and pi over 6 to the left, which gets me to negative 2 pi over 6 or negative pi over 3. So the distance from asymptote to asymptote is in fact pi over 3. Okay. The quarter marks halfway between 0 and negative pi over 6 would be negative pi over 12. And this would be negative 1 pi over 12, 2 pi over 12, 3 pi over 12, which is negative pi over 4. And then 4 pi over 12 would be, so each one of these marks is a pi over 12. 1 pi over 12, 2 pi over 12, which is correct. 3 pi over 12, which is pi over 4, and 4 pi over 12, which is pi over 3. Okay, so at the quarter marks, we should be at a value of 1. Okay, but normally we'd be up here, but it's flipped upside down, so we're going to be down at negative 1. So down here at -1, over here we're up at +1. And there, my friends, is your tangent graph. Okay? Hope you enjoyed this video. Thank you for watching, and I will see you soon.